Thanks, Andy. Yeah, good afternoon, everybody, or good morning, depending on where you are. What we would like to do today is go through the following agenda. We would like to give you a quick Vesta overview, and we'll keep it to a few slides. Talk about problems and challenges with preventive maintenance today, how you can counter those by using CBM, the methodology of condition-based maintenance, as well as the Vesta CBM tool. What do we think condition-based maintenance is and how we can apply it? I will give you some examples as to how you can use CBM in the condition-based maintenance environment to enable equipment to feed their information and their statuses into SAP. I will give you an overview on the complete solution topic here as to what the solution contains, what pieces are part of it, what the requirements are, and how you can set it up. And then dive right into a live demonstration. So we will not only give you some slides, but we will also show you the solution live working against our SAP system. Finishing with a summary and adding the Q&A to the end. As Andy pointed out, please feel free at any point in time to post questions into the Q&A panel. We'll take those up at the end, but you don't have to wait to post them in there until we are at that section. Let's start with a quick Vesta Partners overview. Vesta Partners is a global consulting company. We're focused exclusively on enterprise asset management, or in the old terms it was called plant maintenance. But we see it encompassing more than just the maintenance side. It literally starts with the asset and includes everything around the asset. We offer enterprise asset management solution, as it says here, as the first topic. What does that mean for us? It starts at the business process level with business process consulting in the maintenance space, and goes all the way into the implementation of SAP's EAM module, or plant maintenance module. That is one of our core skill sets and one of our core deliverables. The division I'm responsible for is taking care of everything that is surrounding SAP's plant maintenance module from a technical perspective and from additional software products. What you see on the next slide is the list of software products we're currently offering and the technical services we also make available and deliver to some of the customers. And here you see what we mean with technical services. It's essentially the bits and bytes stuff around the core SAP ERP solution that my team is usually responsible for. Let me go quickly through the software products list from the top of the page. I've indicated the ones that we want to talk about today, Vesta CBM and MII in red. I've indicated MII in red simply because Vesta CBM was built as an add-on on top of SAP MII. So if you install Vesta CBM, you have to have a license as well as a server set up to run SAP MII. The software products, the other software products we have in-house and we delivered, are obviously all in line with SAP's white spaces. Those are things that SAP in its standard offering does not offer, and that's why we jumped on them and deliver a solution for that. And that is the core differentiator of us with other customers, or with other partners, I should say. Let me go through that list here now. Vesta PMX is an Excel SAP plant maintenance integration solution. It allows you to take work order information into Excel, modify order over there, and then transfer them back. MAC is a mass material availability check and provides you, as the name indicates, mass material availability check functionality in SAP. Vesta QMC is a calibration add-on to the QM module and makes the configuration of calibration definitions much simpler in standard SAP QM. And Vesta PMM is an integration to Microsoft Project. It's a very lightweight integration, so you can, with an MS Project, take work orders out of SAP, move them into MS Project, schedule them in MS Project, and transfer them back. On the specialty and technical services side, you can read through it yourself. We're offering a variety of specific technical services, and this is just an extract of what skill sets we have in-house. But these are the predominant, I think, areas where we have lots of references and experience to go back to. Some of our customers, and as you can tell, this is a pretty big list. You might find yourself, or you might find other companies that match your industry. All of these industries or all of these companies Vesta work with on an enterprise asset management level. So we as a company do not do anything but EAM. That tells you that every single customer on this slide here is a customer that we worked in some form or fashion with in the EAM environment. Vesta is a global company now. We have our headquarters is in the United States, but we also have a European headquarter in The Hague, and we have a very strong presence in Europe. Vesta Canada and Vesta Australia Asia Pac are two subsidiaries as well that we can call our own, and we're very proud to be globally represented now. Let's dive into Vesta CBM. What we see in most organizations today that we usually see a time-based maintenance practice where work orders are kicked out for specific equipment in a given time interval. That is, every 4 weeks or every 2 months, or depending on what your maintenance cycle is for that particular equipment. You have work orders being created in the system. The technician is doing the regular execution of the work order, feeding the results back, and hopefully also feeding the conditions and current statuses into a notification. The challenge we have with that approach, and the challenge you usually have, is that you cannot identify problems between the scheduled inspection. So you might not have a work order being kicked out every week, but you might do an inspection round through a paper-based process or through utilizing standard SAP/cycle functionality with inspection with the rounds product. But you still have a lack of visibility when you're not standing in front of your piece of equipment and monitor it continuously. The other challenge we see is that by taking the time-based approach, you're literally not paying respect to what the equipment is really doing, or is it really working. So you might have pieces of equipment that are part of your process but are not actually running 100% of the time. So in that case, do you really want to apply the same maintenance cycle to those equipment that you apply to others? And that's one of the pieces of the basic problem that we see. So failures don't happen at fixed time. Failure patterns are usually more random, but they are certainly based on a distribution. And one of the distributions I've visualized down here. When is the failure going to occur? That's the $60 million question. If we can help you with that to anticipate that a failure is going to occur, that will help you and your maintenance organization dramatically, because you can counter that before it's too late, before it has a sizable impact on your operational business. How do I detect that? That's the other part of the question. And as I mentioned before, why do I perform maintenance activities with the same intervals on equipment that are not running as frequently as others? The answer can be, or part of the answer might be, condition-based maintenance. You want to maintain the equipment before it fails. You want to counter whatever is wrong with that equipment, whatever changes its status, to counter the failing equipment. How you can do that is by monitoring the equipment condition and trying to anticipate or predict the future trend of the equipment. And there are various methodologies that you're probably familiar with that we can use And I will show you some that we have seen very successfully being applied. You obviously want to execute your maintenance using that information. So if you realize that your condition is degrading on a particular equipment, you want to counter that by doing maintenance on that equipment. What we see CBM helping you with is better planning, obviously better safety. If you do not stop your process and you do not have any unforeseen situations, it's always safer. And ultimately, if you're only doing maintenance when it's really required, it's a total lower cost of ownership for the whole environment. How do we get there? What are the challenges? Challenges is essentially that you usually already monitor most of your equipment these days through operational or industrial systems, SCADA systems, manufacturing execution systems, a variety of systems that is connected to sensors and tag data within your equipment that are monitored for operational purposes usually. So people want to know whether or not my machine is running or it's not running. The same exact information you can use to optimize your maintenance program. And this is what the second piece is all about. We can use the up and down time to give you an actual number of runtime hours, not just a approximation. And you do not have to do the manual intervention. What does that mean? Rather than me running around every week with a floor gun in my hand, I can simply put temperature sensors on the same equipment if they're static and feed that information continuously into a monitoring system, which is then using Vesta CBM to inform the SAP ERP system and the maintenance team about possible events that might occur. Let me give you some very specific examples just to show you how this can be of help to you. I already mentioned the example of production line runtime hours. So let's assume for a moment you're a manufacturing organization and you have production lines. Those production lines usually are maintained based on a certain interval right now. What you can do is you can, by simply taking the information whether or not your line is running or not running, so it's on or off, summarize the on events over a 24-hour period, which results into your actual production line runtime, and post that to a measurement point. What do you get with that? Well, as I mentioned before, you can now set up a maintenance plan that is in line with your actual runtime of the pieces of the equipment that you have as part of that production line, rather the time that, between 2 days. With that, you usually reduce your maintenance effort because you do not have to do maintenance quite as often as you sometimes think. That production line might be down over the weekend and nobody's accounting for that. The production line, is not running because you don't have market demand for this type of product, yet it is still maintained. Obviously, you have to balance that with your operational needs, but it certainly gives you better indicators as to what you have right now. Bearing heat differences. When an equipment goes faulty, or some of the equipment have this pattern that if something is going wrong, and we like to use the bearing problem as an example, what you will see is that the heat on that equipment is changing. That's the same concept that you see utilizing a flare gun. What we are advocating, though, here, rather than having to go walk by the equipment, what you can do these days, very simple and really very cost-effective, is put a temperature sensor onto the equipment and measure the temperature continuously. What you achieve with that is you can, over time, detect temperature differences and alert people about that fact. As a result, you might send out a notification to a maintenance technician saying, that bearing temperature has increased from last week or from the last time I checked, by 10 degrees. So you might want to take a look at that bearing because it's about to, it's about to break down. And it certainly does not, it certainly pulls more power and requires the engine to work harder. We have some situations where we want to take immediate action. Some examples are, in the hydro generation world, where we have dams that are feeding generation facilities. If those dams are breaking or leaking, you want to be notified of that, not only because you have environmental impact, but also because it might have an immediate impact on your generation capacity. In manufacturing or processing environments where you have lots of fluids that are pumped through a system, you might also have situations where you want to check whether or not you have any leaks. That can be done with so-called ball float sensors. They're detecting leakage in housings or in bigger environments. Bottom line is, what you can do here is you can take that fact or that sensor output and feed it directly into a notification and work order. And at the same time, again, CBM also allows you to send notifications out or send email notifications out, I should say, if that's necessary. The next example I have here is about railroad cars. Railroad cars are very sophisticated pieces of equipment these days. They analyze their own bearing temperature, provide you exceptions, and once the railroad car or the train actually passes through that AEI gate, the automatic equipment identification gate that you see down here, it is posting the conditions to those receivers here, which in turn end up usually in a central database. So that central database contains all the exception items that you have on that particular train. Now that's usually where it stops. The railroads obviously do not want to have that information just in the database. They want to have it in their central maintenance management system, being SAP. That information can be posted into SAP by utilizing CBM as well. So CBM has the capability to take that database content, merge it, and apply it to the appropriate technical objects in SAP, be it functional locations or equipment, and that certainly depends on how you structure your rail car within the SAP structure. The last example I have in my list here is a classic utility transformer example. Transformers usually have an oil cooling system, and what we have here is essentially a situation where we want to be notified if the oil temperature exceeds a certain threshold. What usually happens in a perfectly working system is that a cooling fan kicks in and cools down the temperature, and you would see a temperature, turning downwards as we see here in this picture. If the cooling fan is not kicking in, that's usually an indication that either the fan is broken or the sensor to turn on the fan is broken. Either way, you usually want to do something about it, and you want to be notified about that situation. Now, the situation is becoming more imminent if the second or third stage of cooling is also not kicking in. So if we're exceeding yet another threshold and the oil pump, for example, which is sort of the last stage of the cooling cycle, is not kicking in, that's when we want to certainly raise the stakes, maybe create a work order and send out an email to the responsible maintenance group to say, you need to take care of that transformer because it's about to have a sizable impact on the grid itself, but also on the long-term viability of that transformer. Let's talk a little bit about how we can make that happen and what Vesta CBM, the solution, is all about. Vesta CBM, as I mentioned before, is this red, or is indicated by this red box here on top of SAP MII. So prerequisite for the Vesta CBM is SAP's MII product. SAP's MII product stands for Manufacturing and Integration and Intelligence. It's a, it was a company, or SAP acquired that years ago from a company called Lighthammer. And that's what we are utilizing as our foundation to put the Vesta CBM out-of-the-box functionality on top of that. Vesta CBM can use, and that's certainly what we're advocating, using data historians as the feed to get all of those real-time data feeds, like current voltage, temperature, whether or not an equipment is in operation, whether or not it's leaking, what the temperature is, et cetera, et cetera, et cetera. But we can also take calls from monitoring systems. So if you have monitoring systems already for operational purposes that are feeding out warnings, that are pre-processing condition data and only send exceptions to SAP, or wanting to send exception to SAP, you can use Vesta CBM as your interface to SAP ERP as well. So that's what, in technical terms, we call web services calls. And we have a UI entry capability where we can allow readings to be entered into CBM, which then can translate into a notification being created or a measurement point being fed in the SAP system. The reason why we put in this manual functionality is that sometimes you have 20 production lines. Ultimately, we want to get all the 20 lines wired up and fed into the data historian, which in turn then feeds through Vesta CBM into ERP. But sometimes you only have 19 lines available. So what am I doing with the last one? I obviously do not want to use a different process from an ERP perspective for that one line. So what you can simply do is you can enter the pertinent information through manual readings via Vesta CBM into the ERP system. Our vision: we want to simplify the acquisition, analysis, and use of the equipment and line condition data in support of condition-based maintenance strategies in the SAP plant maintenance ecosystem. We obviously want to minimize custom coding. That's why we build a standard solution. What you usually have to do is you have to take a product like MII and then start coding. And what we have seen, and that was the biggest complaint we had from customers, is that every single time a new equipment comes in, it's wired up, it has some tags that are feeding into the historian, and I have a functional location on equipment in SAP. Now I have to do custom coding again in order to link that and make it work. It usually takes a long time, it's very error prone, and it's not easy enough so that a business user can really do it. That's what we have countered. Vesta CBM allows you to do exactly that. And we're leveraging existing infrastructure, because you usually already have an operational system or an industrial system that you're already using. You have already SAP, and in a lot of cases that we see, you already have an MII license as part of your licensing. You have everything in place that you need as far as foundational pieces. So the only piece that you need to put on top of it is Vesta CBM to make it easier to enable this connection. SAP MII, as I mentioned before, it stands for Manufacturing Integration and Intelligence. It's an SAP product. We see it as a very awesome toolkit for rapid development and of specialized application. The big functionality that it brings for us is, number one, the connectivity, and number two is the development tools. So we allow you to extend the standard CBM functionality using standard MII tools. So there's no special knowledge needed. As long as you have MII developers in-house, you can extend and enhance the functionality of CBM overall. What you see in this slide is another slide that shows the MII system as well as the connectivity to ERP and other systems. Down here you see the industrial systems that are currently supported, or the so kind of the types of industrial systems, I should say. With SCADA HMI services, with DCS systems, MES systems, custom databases, plant historians, all of that is already built in, and because we're having Vesta CBM built on top of MI available immediately. Vesta CBM, the key features, it's a simple configuration process with standard rules that you can set up, and I will show you that how quickly and how easily you can match up one or multiple tags on one side with a function, location, and equipment, and put a processing rule in the middle. We have flexible data acquisition. What we can do is we can just simply track a value. We can capture a value, and we can post a value. What's the difference? I'll come to that a little bit later. Posting essentially means at that point in time you're posting information, or you can post information as a result into SAP. Alert management. The alert management allows you to do little things like sending an email, or more complex things as creating notifications and work orders in the SAP system. You can also just post measurement point information on a continuous basis. All of that is part of the solution. The SAP integration was an integral part of our design. So this product, Vesta CBM, was built on top of SAP. So it's not a CBM solution that was built, around CBM and might have an integration to SAP. SAP integration was the key aspect of this product. So in everything you do, in everything you find, you will see that it always looks at SAP and utilizes the best practices of the SAP EAM environment. This is a slide that we used very early on to sort of summarize what is important. We want to be able to select an asset, select a rule, associate the necessary tags and fixed values, and define how often that check should be run. And it's as simple as that from a high level, but that is what currently is missing in the product environment. We call it a CMP, condition monitoring point. These are all the information that's going into the condition monitoring point, and I will show you that as soon as we're jumping into the live presentation. I don't want to talk too much about architecture. I just want to show you that we have a very structured flow through the components, and I will go through the individual components. On top of that is a user interface, and we have two user interfaces available that I will show you a little bit later in the presentation. The data source integration, we are using the MII features to connect with various data sources. As I mentioned before, you can connect various data sources starting from databases to historians to SCADA systems with Vesta CBM. We can wait for notifications. So if your database sends us a notification that something is off, we can translate that into SAP speak and create the appropriate document for it, either notification, work order, or measurement point. Or we can query either an equipment or a historian that captures the equipment history over time on a timely basis, on a repetitive basis to determine whether or not there's something for us to do. The rules processor, the next piece in the list, is taking care of the decision making. What am I going to do with this fact or with these facts that I have? The temperature is X, the temperature threshold is Y, the fan is on, the oil pump is off. So what should I do with that combination of information? You usually cannot make that determination in standard SAP ERP very easily, and that's where the complexity and where the capacity and capability of Vesta CBM comes in. The rules processor can process something as simple as unit conversion. Your historian might give you the information in minutes or seconds, but SAP would like to have it in hours. So that unit conversion is one example of a rule. Another rule might be the summarization of up and downs over a 24-hour period. that might be a more complex example of the rule. Important to know is that we at Vesta deliver and will continue to deliver standard rules for equipment or equipment families, but we also allow you to add custom rules to it. So if we have not yet provided the correct rule for you or for your equipment type, you can build additional custom rules in addition to what we provide out of the box. Alert and exception management. We allow you to take that information, everything we have learned, and document it. Readings are documented, and alert and exception management is essentially the follow-up on a rule. If that rule determines that you should notify somebody via email, just on a web page, or as part of a notification in SAP, all of that is done by the alert and exception management component. And last but not least, the ERP integration. The ERP integration makes sure that everything in connection with SAP ERP is done the SAP way. But that is ensured already by utilizing two SAP products that are working seamlessly together. What Vesta CBM allows you to do is three things, or three postings. We allow you to feed measurement point documents, so measurement documents. We can create notifications, and we can create work orders with or without task lists or the use of task lists. We can also enable custom processes that we currently cannot think of, but those are the three most common ones that we've seen and that we want to support with the first version of the out-of-the-box product. We have some other integration points with the ERP system, namely on the master data download side. So we transfer technical object information into the CBM product just to make it easier for you to do the assignments, and I will point them out a little bit later. The user interface, we have, as I mentioned, we have two user interfaces. One is for more the administration and configuration tasks, which I will show you in a few minutes here. And we have a web-based user interface that you can use for the occasional user, usually for the technician to look up whether or not there are any alerts in the system and to enter measurement point documents or measurement documents. This is a screenshot of the user interface that you will see in a minute in live demonstration. And this is a browser-based user interface to show you the description and some of the alerts that are going on in the system. Here's an example of the manual data entry. So you can feed a manual entry into the system, and you get all the information for the tag that tells you what the upper and lower limits are. With that, let's go right into the live system. What I want to do first is I want to show you, log in first. I want to show you the standard functionalities that we have in the system. I already talked through them on the slides, but now you can see them in real life. So the core piece is the CMP, or the condition monitoring point definition. Here you see the CMPs, or the condition monitoring points that I've already set up, and matching the examples that I have. I have a van, and for that I do odometer readings. Because I don't have any technical link set up for that, I do a manual feed. I have the pump leak response, where I'm tracking a tag and I'm feeding that into an equipment. I have runtimes hours being posted against measurement point 11801 for that functional location here. I have the railroad tracking exercise that uses an external data point. And I have the transformer oil temperature checking that is essentially feeding notifications into my system. So all of that you can define in the CMP here. We'll come back to the CMP a little bit later when I set up a real example. In the alerts functionality, you see the alerts that were raised, emails that have been sent, or notifications and work orders that have been created. And to the right side here, you see when that happened, who it was created from, what type it is, what the status is. All of that is available in the alerts section. Tag maintenance allows you to take tags, and tags might be a misleading misleading term here, but tags out of a historian usually have a name and they have a current value, and they can provide you with values over time. What the Vesta CBM tags add to that are various limits, a description and a target value. So here you see that my all temperature tag that I currently have in the system has a target value of 30, an upper limit of 45, a high upper limit of 75, and 2 lower limits of 10. So all of that is specified, and I will go through that with you in more detail in a minute here. Manual entry, this is the screen where I see what manual entries are enabled, and I can post an additional manual reading to that particular tag. In my case, it's an odometer reading. I don't have any limit specified for that. The last posted reading was 140, so let's enter 150 into the system. Hit create, and what that does, it essentially enters the reading into the system. The next functionality here allows me to look at those readings. So I can look up all the readings that I've made for my van. As you see here, the status of this van posting is still pending. It has not created a measurement point in SAP yet, or a measurement document in SAP yet. But that can happen in the next few minutes. Here you see the creation time of all those readings that I've posted. Now, if I switch to another tag that is not manually but automatically fed, we, for example, have the oil temperature here. The oil temperature is fed in from a tag simulator, so that automatically and continuously provides me new information and changing information. So this are the readings that are read every 10 minutes, as you can see here, and they are provided as readings and then analyzed. External data points. External data points is a good example. Well, the good example is the railroad AEI gate. So there's an external system that is doing the pre-analysis of whether or not something is wrong but should be posted to SAP. Our external data point can take and receive that information, process it through one of our rules, and then determine what alert should be raised, whether or not it's just an email or an email and a notification, or other pieces that we have to take care of. Master data. We have master data that we're downloading from SAP that can be either a manual download, as you see here through the download button, or it can be an automatic download that is scheduled every once a week. The reasoning behind it is we want to make sure that all the technical objects that you want to select are already in the system before, and we don't have to communicate with SAP every single time you click on a button to select a function location. The email management functionality allows you to set up individual emails, as you see here, as well as distribution lists. So if you have maintenance teams that are reactive maintenance teams and should be notified immediately if something happens, you might want to add them in here as a distribution list and then specify them in the CMP. Let's put a complete example together. The first thing I want to do is I want to create a new tag. Let's assume for a moment I have a new transformer that came in. I want to monitor its oil temperature. And whenever the oil temperature exceeds a certain threshold, I want to send a notification to a particular functional location in SAP. That is my simple scenario that I will use as a starting point. And what I want to do now is I want to guide you and walk you through the steps in the next 5 minutes or so to set that up. So assume for a moment that I'm a business analyst. My technical crew or my electrical crew gave me the information as to what's the tag name in the historian, and I also obviously know is what functional location or equipment did I create for this particular transformer. So the first thing I need to do is I need to maintain a new tag. I go in here, I click the new tag functionality. I specify a tag group or tag name. Let's call that demo transformer tag temperature. given that I don't have a running OSI system, we're using a simulator for that, but we've tested this functionality with a live OSI system as well. You see here that I get a list of tags, but all this list gives me is a tag name. And if I find my oil temperature tag, here it is, I can specify that. As I mentioned before, the additional information that you can provide within Vesta CBM are information about what's its target value. So let's assume my target value for that temperature is 40. My upper limit is 50. My high upper limit is 70. Lower limit is, in my case, 10, and lower limit is 5. The description that we have here is just temperature tag, and the unit of measure is degrees Celsius in my case. Finishing that up is the first step in order to enable that. So what I've done now is I've declared the tag that I need to Vesta CBM product. The next step that I need to do is I need to create a CMP. So in this case, I can decide whether or not it's an external trigger source, I want to feed manual entries, or I want to use condition monitoring. In my case, it's condition monitoring. And we want to create a notification if we're having any threshold exception. So there are a few things that you now have to provide. You have to provide a technical object. I can use the top-level function location, as I do here, as my starting point. And what you can do then is just like what you would do in IH01. You can go through the tree, find your equipment as well as measurement points. Let's see if we have a measurement point here somewhere. Feed and see your measurement points, assign them, and make sure that that the right technical object is selected. So you can pick and choose your technical object that you would like. In my case here, we want to create a notification, and we're just using that line 8 here as a target. As far as tag, I'm selecting my demo transformer tag. That's the tag that is providing me information on top of which I will make a decision whether or not to create a notification for that line 8, yes or no. And the last thing is to specify a name. So in my case, I will just use something that is easily recognizable to you. Whenever you're going live with a solution like this, you will put much more emphasis on having a more consistent CMP naming. But for this particular demo, I just stick with that. So with that, you have the bare bones CMP or condition monitoring point created and enabled. Now in order to complete that, I go into the edit functionality here and go through the different types of tabs, I should say, or different types of setups. In the general section, you can find information about the execution type. I alluded to that earlier. So you can either just capture the reading, and that might be the first stage. So now you have set up that connection, but rather than posting notifications, you might want to track that tag over a time period of 24, 48 hours to see whether or not the values that you're getting are consistent and are matching what actually happens in real life. Then you have an alert mode. The alert mode is taking this to the next level and essentially monitors the tag value against your thresholds, the higher and lower thresholds that you have. Alerts can be raised, and alerts can be to the website or the email system. And last but not least, we have the post mode. So the post mode allows you to specify email notifications or work orders and post that to the SAP system. Same for measurement documents, by the way. The data trigger, in here you can specify how you get the information posted into this condition monitoring point. It can be PICO. PICO is a component of SAP's MII that can make a preliminary determination as to, okay, this is something you want to be notified of. We can also schedule it. As I mentioned before, if we want to check the temperature every 10 minutes, that can be done, and this is how you would set it up. Under alert management, you can decide what and how you alerting should be done. It could be just to the web page, and the web page essentially means this is the alert mechanism that you see in here, or you can use it through the web page. But you can also specify email and web page, in which case, in addition to posting it to that web page, an email would be sent out to the end users. Rules. The rules section is an important one. By default, we are having a processing rule in here that says tag threshold range monitor. What that does is essentially it compares the current value it gets from the tag to the thresholds that you set up in the tag definition. If any one of those is exceeded, the result will be that an alert is raised, and if necessary, a notification is created in the system. But when you look at the drop-downs here, you can see that, number one, you can have custom rules. You can have custom processing rules, as I have here. For the one I built real quick was the Vesta summarized work hours across 24 hours. Or you can have simple conversion rules. An example here would be seconds to hours or seconds to minutes. In the destination tab, you find some more information about additional information that SAP needs in order to create a work order or a notification. In my case, what we need to specify here is a work center and a notification type. And that's all I need in order to set up my condition monitoring point. So as you've seen, in 5 minutes, I set up everything I need to set up in order to link a tag with an SAP system. The only thing that is missing is now to enable this condition monitoring point and put it to work. And what it does now is every 10 minutes it will go out, check that tag value that we specified, see whether or not it violates any of the thresholds that we have also entered, and if that's the case, create a notification in SAP with all of those facts. So with that, I want to stop on the demonstration side and jump back into the presentation. I have 2 more slides before we open up the floor for questions. Implementation. CBM can be set up very quickly. What do we mean with quickly? We're literally talking about a matter of days. I've done it and set it up completely from beginning to end in as little as a few hours. But if you have never done it before, you might take a day or two in order to set up everything. It can be, you can use the standard SAP authentication concept. So it's built on standard SAP technology. It fits right into your SAP environment. There are no surprises there. It allows you to utilize existing user definitions that you might have done and just create an additional role in order to define what is actually, what you make actually available to the end user and what you do not. If you need it, customization is available. I think I've mentioned that a number of times. If any of the rules that we have and we provide to you as part of the standard package is not matching your needs, you can either ask us to build you new ones or build new ones yourself. And you would just use the standard SAP MII skill sets that you probably already have in-house to fulfill that. To summarize, what were the challenges? Well, we had untapped investment in historians or monitoring data systems. We have, at the moment, limited visibility to condition data to make the correct decisions. And we have lots of systems that collect lots of data, but it's in a lot of cases not utilized in SAP. What CBM provides to you is an intuitive user interface, as you've seen, for the business analyst to set up condition monitoring points in as little as 5 minutes. We can specify mappings. We can create measurement documents, work orders, and notifications, and if you need anything else. And as far as business value, we think we are increasing safety dramatically, improving reliability, improving maintenance planning and execution, and overall decrease maintenance cost. With that, I would like to ask Andy to step back in and see whether or not we have any questions in the Q&A panel.